So good morning. My name is Salem Al-Laqdash, as Jose has introduced me, and it's a pleasure for me today to speak on behalf of our partners of the Iranet Mid project on the design, development, and demonstration of the 3D microgrid system. So what I will do today is give you a brief presentation on this project. So I will give you some background information on what we are going to do in the project, we have done, and what we are going to do in this project. I'm going to give you some, idea or summary of the activities of the project, some scientific contribution in the microgrid context, the architecture that has been proposed by our colleagues in the project of the 3D microgrid, and we will discuss some of the components that we have achieved so far in this context. So this is the definition of the project, what we call as design, development, and demonstration of a smart microgrid. And the objective here is to create a new and inclusive interactive microgrid demonstration site for various types of distributed resources and the control strategies. And that could be something that we can demonstrate at the sites of Malta, our partners in Malta, and also at the site of German Judaic University in Jordan. And this could be something that we can replicate afterwards in other sites to launch the idea of smart microgrid across the different regions. So we're trying with our partners, with our experts, to install and produce or introduce a state-of-the-art architecture of this microgrid system. And in fact, as maybe all of you are aware, this is a topic that is very interdisciplinary. So you have to have different sciences, different experts from fields in computer engineering, in programming, in architecture, in power system analysis, in optimization, on stochastic modeling, and all these kinds of things. And this is exactly what we have as partners, whom I will introduce in a few minutes. We are working together in putting together this state-of-the-art architecture. And in fact, this is a project that has been funded by the Iranet Med FP7 project. So we have partners from, so Jordan is one of them, then we have Malta, Cyprus, Turkey, Germany, Greece, and Spain, and Algeria. And all of these partners are working together, but they're funding from their local funding agencies. So this is the context of the Iranet Mid project. And it enhances and it creates more cooperation in the European Mediterranean countries. And in fact, it's very much focused on capacity building, because through this project we aim to have more experts and more people who are doing research in the area of microgrid, smart microgrid systems, and enhance the mobility between different partners in different countries. And this creates more cultural understanding, more literacy understanding between the people in our region. And in fact, we have been working together as partners to expand our cooperation in the wider international context. So I know my colleagues in Greece, they have been presenting a paper, or they will be presenting, hopefully they did, or maybe today or tomorrow, in a conference in New Delhi. And we have our partners from Malta. They're also presenting a paper at the end of this week in Japan. So we're trying to expose ourselves to more in the international context of what we're doing. So I just want to give you some background on how did this project evolve. And I remember when we started the cooperation in this project, we went into context, why 3D or why microgrid is important for our countries. And, there are lots of benefits, what we call here as prospects. So enhance more of use of renewable and diverse energy resources, more to reduce environmental impact, to create less environmental emissions and problems that does not nice for our environment. And in fact, it enhances the localized generation and control, and leading to robustness and resilience. So you don't much depend on the grid if there are problems and issues, but you very much depend on your local generation resources. And this creates more resilience in the use of power and energy resources. We're trying to put more effort on the optimization, scheduling, local scheduling of generation resources, as well as for the management of energy resources in the local context. So as you can see, the broader definition of this project is about small-scale version of centralized electric power system, and the idea is to provide to small communities types of grid systems that you can manage at the local sites. And we're trying to build the smartness, autonomous, the intelligence into the operation and management of microgrid systems so that we can generate and distribute and regulate the flow of power to consumers in the local dimension. Local dimension, it means in the same site. And as I said, because there is a key word in the name of the project, which is called demonstration. So it's not only just to introduce design and architecture and introduce the development of what we're doing, but we want to build this in reality. And this is what we want to demonstrate in local sites. And the two local sites here are the university in Malta and the university in Jordan, the German Jordanian University. And so we want to launch this smart microgrid in campus for both environmental and economic benefits. And this is what we aim at the end of the project. We started in the project about a year ago, and we're aiming for another 2 years to finish with the objectives. And as I said, those are the partners of our project. So German Jordanian University in Jordan is the coordinator, Malta College of Art, Science and Technology in Malta, University of Cyprus in Cyprus, Abdullah Gül University in Turkey, Center for Research and Technology, Hellas in Greece, GeoCES in Malta, University of Sevilla, Spain, Energetics in Germany, Ikola National Polytechnic di Oran in Algeria, and Electric System Design LD in Malta. And this is the group who have been working together, and this is the picture that we took about a year ago. Maybe some of the partners they're missing. I'm sorry for this, but you did not attend a kickoff meeting. We tried with our photoshoppers, but it did not work. So I could not really place where the missing people could be, but it's a big consortium. So the main activities for this project, as you could see, before you begin any project, you have to explore the requirements. So, what are the different operating scenarios? And we have been discussing this and over with our partners. We have very good people, very good experts, very good researchers who have been contributing largely into the project. To explore also the constraints and requirements, definition, evolutionary requirements, refinement, and performance modeling and characterization, the framework of what we want to do. So this is the, any project, if you want to do any design, any development, you have to explore your requirements. You have to identify what are the definitions, what are the requirements, what are the constraints, what are the operations. And there are different tools that you can play with and you can use to set up these requirements and understand, what exactly are they. So there is use case modeling, there is UML diagram that you can put together to understand these requirements. And we have done quite a lot of work in this dimension. And then you try to put together an architecture that can help you to achieve what you have done as a requirement. So this is about monitoring and architecture of monitoring and control architecture. So now you can see there are two key words here. One is monitoring and the other one is control, because grid systems, they have to operate in real time. And if they have to operate in real time, you have to keep monitoring of what is going on, collecting data, identifying all kinds of constraints and meeting all those kinds of constraints so that you can achieve the real-time objectives and the real-time operation. And in power systems and grid systems, you have to achieve the balance between generation and demand. You have to achieve the voltage levels at certain voltage levels. You have to achieve certain frequency levels in the system. Otherwise, there will be lots of cascading and disconnection from the grid. And this is exactly what we have been trying to put together as a simulation model, as a definition of this SCADA, System Supervisory Control and Data Acquisition for Monitoring and Control. And we will see in a few minutes architecture that has been introduced by our colleagues in Greece, on what we want to do as a centralized controller and the optimization models that are required for this. And as I said, we have to do demonstration because we have to prove the concept. And so the demonstration and prove the concept is to do the pilot demonstration. As I said, so we want to do pilot definition, pilot validation, evaluation, and do some benchmarking for the future larger-scale deployments of the system. So, in fact, because this is more or less a research project that we want to build together with our partners, so there is an objective, a scientific and technical objective that we are seeking to achieve. And this is primarily focuses on the establishment of decentralized control paradigm, such as voltage control, demand response based on available power resources and dynamic loads. And because very much we're using software, so we want to introduce and develop open source smart microgrid framework. So this is a project that we want to introduce to the communities. So hopefully by the end we have a piece of software that we can launch and we can put it for the communities to use. Design modularity and for scalability of smart microgrid functions and develop robust autonomous agents for the smart grid paradigm. So maybe some of you are familiar with the with autonomous entities, complex adaptive systems that you can introduce and you can put to control elements and nodes of power system. And agents have been seen as the solution for many of these software, for many of these control and management systems that you can introduce at different nodes in the power system. So we're building together an agent system, autonomous, smart, intelligent type of agents that we can manage and control. And I will show you some of the diagrams that we have. And in fact, you could see this is a graph that I put together on, if I want to really identify what is a macrogrid system, this is exactly what it says. You have renewable resources like solar photovoltaic systems, you have energy winds and turbines, you have generators because you have to have some generators to accommodate if there are shortages involved in power generation at certain sites. So we need to have these generation sites somewhere. And in fact, one of the most important, because you're operating this microgrid either connected to the grid or isolated, but you have to have a storage where when you have excess of power, you can put on the storage, and when you have shortage of power, you can get from the storage. Because then you can maximize the economic benefit of the renewable resources you have on site. And of course, you have to be connected to the grid because there are times you have excess of power, and not all of them are put in the storage, and storage is very expensive to install on sites. So you can send to the grid, and sometimes if you have shortage of power because there is no wind, or maybe the sky is cloudy, so you don't really get much power, so you get power from the utility. And this is, in fact, there are lots of research on this two-side power flow. You have power flow that comes from the grid to the macrogrid, then you have a power that is of excess, and you can send to the grid. And of course, your load is the buildings, the site that consumes the power. And because it's a macrogrid, you have to control this macrogrid in real time. So you have to manage and maintain the balance between load and generation. You have to maintain, as I said, the voltage levels, the frequency, the power flow, optimization, all these kinds of things. So you have to have a control system. And as you know, this is exactly what we're trying to achieve together in this project, is to introduce the idea of control paradigm that manages the macrogrid system. So this is a graph that has been nicely put by our colleagues in Cyprus. I like this graph very much, and that's why I chose today to present, and has been also put in our conference paper that has been accepted in the IEEE conference in New Delhi this week. And so, in fact, you can see the control has to be reconfigurable. It means that sometimes the macrogrid is connected to the grid, so this is a grid connected, and sometimes it's isolated. This is an isolated control operation that you have to maintain. And in fact, everything is based on a multi-agent system. So you can see this is the diagram that shows we have different levels of components. So some of them on the grid and market services, some of them on the tertiary control platform, some of them on the secondary control platform, some of them on the primary control platform, and some of them on the generation and distribution and generation and demand forecasting. So I will briefly explain these components that you can see on the left-hand side. So these are mainly the components, whatever. So, okay. But the challenge here is, if you are familiar in the power system analysis, the challenge here is in the bidirectional power flow. So, how to manage this in real time. There is, you cannot really very much dependent on the renewable energy resources because they're very intermittent. Sometimes you have this power, sometimes you have less power, and sometimes the sun is nice, sometimes the wind is high, and so on. So it's very intermittent that you can't really depend very much. There are lots of nonlinearities, high nonlinearities in the operation of this system. So you have to explore and to understand all of these kinds of requirements. And there are dynamics that keep changing, and the uncertainties are too high in this kind of project. And those are the big challenges that we have been struggling together with our partners in this project. So as I said, the components that you have seen in the graph, one is on the grid and market services. And this is, in fact, very much focused on the interconnection with the grid. So what are the voltage levels? What is the power flow in the two directions? Because very much depends on the pricing of electricity in the grid. So what is the market prices and what are the ancillary services that keep up the optimal power flow on the system? The second component is on the tertiary control platform, and this is very much focused on the operation planning. So on grid, optimal power flow, day-ahead power dispatch. And the third component is on the demand and generation forecasting. And so this is on the stochastic prediction of load profiles and distributed energy resources generation. So those are the main components of this, the main elements of this component. The fourth is the secondary control platform, and this is focusing on the off-grid transition control, agent balance. And the primary control is about the autonomous agents that we want to install for each node to maintain the voltage, the frequency, the active and reactive power balances on the different nodes. So this is the hybrid multi-agent system that also our colleagues in Greece have been introducing. So you can see three different elements, one on the centralized, one on the semi-centralized, and one on the decentralized. So there is a paper will come very soon in this system that exposes and explores all of these dimensions in the macrogrid system. So I'm not going to go into details here, but we have a meeting tomorrow and the day after tomorrow that we are discussing in details how are we going to build and sustain and maintain these kinds of elements in research. So this is my final slide that talks about, just to give you an idea, if you want to build a pilot that it demonstrates what we have been doing, GJU is one of the pilots, and we have MCAST as another pilot. And now this is just like a graphical representation of what a macrogrid would look like. So you can see there are generation resources that are very much dependent here on the renewable photovoltaic system. And we have sites that consume power, and we have connection, switch gears, all these kinds of things that interconnect. And at the end, they interconnect with the grid system, at the point of interconnection. And there is a transmission system, but this is a local transmission system. So with this, I conclude my presentation, and thank you for listening. So if you have any questions, please. Thank you.